So thank you and welcome to this webinar of Basics of Data Science. This is part of our regular effort to really kind of have one pre-meetup webinar on a monthly basis. So last time we had ChatGPT. That recording is already posted in the YouTube channel. I'll share the link in a little bit as well, and a few more resources as we progress. So let's get started. Today's webinar is brought to you by bigdatatrunk. bigdatatrunk is a professional training company founded in 2008, providing technology and soft skills training online and in person for Fortune 500 companies, as well as individuals if they want to upskill and reskill themselves. We are based out in Bay Area, California, but we do trainings all over the US and online, and several times we fly into clients' offices and things like that as well. As you see, most of the categories are technology and cutting edge technology like AI and IoT and a lot of the high-end technology, but we also have the soft skills and leadership training as well. A lot of the focus is around upskilling, boot camps, refreshers, or upskilling and reskilling staff to get into new areas of technology and other spaces. That's very common as well, which is happening these days. So that's a little brief about bigdatatrunk, who is sponsoring and bringing this webinar. We have a lot of different trainings in different categories. We're trying to host a free webinar every month. We will increase the speed, the frequency of it, probably go to twice a month and so if needed, but at least one a month we are trying to do. And we have several different categories in AI, and specifically generative AI has become a lot of focus. We have a lot of trainings. As I mentioned, we had a webinar last month. It's posted out on our YouTube channel. I'll share the links in a little bit. So today's presenter is going to be Aparna, who is part of the bigdatatrunk training team. She's a senior instructor, and we are going to pass it to her. So I'm going to stop sharing and let her take it from there. Over to you, Aparna.
Thank you, Raj. Am I audible?
Yep, I can hear you and I can see your slide. Yep.
Okay. All right. Thanks a lot for that intro. Welcome everybody to this webinar on basics of data science. As a field, probably data science has been around for quite some time. So I'm assuming most of us are a little comfortable, with all the terminology that goes around with data science area as such. But probably, over the course of the next 45 minutes, we will try to put everything together on a common page. What exactly does data science talk about? What are some common tools and technologies that come into play when we talk about data science, and also have a discussion on some real world applications of data science that probably all of us are making use of on a daily basis. So let's get started. So now, probably this is going to be one of the most common definitions, I would say, that we come across when anybody speaks about data science. It's the study of data in order to extract meaningful insights for business. Probably, 2 or 3 really important components there. One is just the data part of it. Huge amounts of data being generated, all sorts of data. In fact, year on year, if we notice the trends in terms of the amount of data as well as the variety of data that is being generated, it is getting massive. We will talk a little bit more in detail about types of data a little later on. But then, what do we do with all this data? Yeah, it has been there pretty much around from quite a long time. So what exactly are we trying to do with this data? How are we trying to pull out some new insights that we probably did not have previously? What are the processes that we need to go through in order to be able to pick out all these new interesting patterns, or be able to make some kind of new meaningful predictions? So how do we do that? And probably most importantly, how does it impact, any organization's bottom line? End of the day, you want it to kind of, make sense to you in terms of how can you make your process better, or how can you serve your customers better? How do you improve your bottom line finally? So data science is this, huge area that combines a lot of tools, methods, and technology across many different areas. And ultimately, like we said, we are trying to generate meaning from all of this data. One thing to keep in mind definitely is that, data science takes on a very multidisciplinary approach. Probably, that is what makes the whole data scientist job so coveted, and probably, at times also makes it sound very abstract the minute we say data scientist, because there are probably, a lot of responsibilities or a lot of different things that go under this umbrella definition of a data scientist. That is necessarily because they have to pull in a lot of skills from across multiple disciplines. For example, a good data scientist would be expected to have a solid understanding of the mathematical backgrounds behind most of the algorithms that they make use of. There's a lot of statistics built into most of these machine learning or deep learning approaches, both of which again pick heavily from the artificial intelligence area. Being able to make good use of all these techniques also necessarily involves some basic understanding of computer engineering concepts. So data science happens to be at the intersection of all of these various different subject areas. One, a good solid foundation of computer science or IT. Probably not, I wouldn't say, strictly necessary, but having a good understanding of the underlying math and stat related concepts also makes it easy in terms of determining what kind of techniques are useful in which kind of scenarios. But ultimately, to be able to get the best use of whatever data science techniques that we are interested in, I think, having the underlying domain or business knowledge is what actually is really necessary in order to get the most benefit out of whatever that we are trying to do. This is probably, a definition that I personally, prefer in comparison to all the Wikipedia definitions that are out there, because it captures, everything that happens within a data science project very, very well. First, you need to have this, I would say, appetite for quantitative analysis. You should be able to work with huge amounts of data, understand where the data is coming from, what the data quality is, how do you clean it up, how do you do data wrangling, exactly which portion of the data is it that would probably give you the most benefit in terms of what you're trying to do. So, the first part is this, being able to do this quantitative analysis on whatever data sets are available to you. Second part of it is having, the necessary programming skills, or at least being able to understand what kind of programming would be required in order to work with whatever data that you do have available to you. And probably, the most important function, or, the role that a data scientist is also expected to play is, once you do have, all these means to work through your data and then get your insights, how exactly are you going to convey it to the, probably, the upper levels of management or whoever it is that is trying to make use of all these new insights that are being developed. So data visualization also forms, a very big, plays a really important role in terms of trying to make sense of all these insights that you have gained from this new data. In terms of data science terminology, again, there is no clear-cut definition, I would say, or clear-cut demarcation between a lot of these terms that we come across. There is some kind of overlap that happens, whether it is data science that we're talking about or artificial intelligence. So the first one, let's talk about artificial intelligence for a bit. Artificial intelligence, again, as an area, it's been around probably from the 1940s, 50s. And incidentally, data science also, as a term, technically probably has been around since 1970, although it has really gained prominence probably from 2008 onwards. In fact, if you just look up any of the history behind data science, there's this very famous LinkedIn post by DJ Patil and another person working with Facebook and LinkedIn together, where they kind of made data science sound like this really cool area and most upcoming job trend. And in fact, that hype has stuck. In fact, even over the last 4 to 5 years, in fact, from 2016 to 19, data science or data scientist was the most preferred job option across the states. And it was the second best, job option for the next 2 years, which was 2021 and 22. So that hype hasn't died down. In fact, it's only getting bigger and bigger. So, one term that we always hear, almost pretty much in association with data science, happens to be artificial intelligence. Are they related? Are they similar or same? I would say, they're two very different, distinct fields that do overlap quite a bit. In fact, bulk of the actual work that we do within data science, apart from the working with the data part, actually, trying to get the insights part of it, makes heavy use of artificial intelligence techniques. And within artificial intelligence, we once again have all these different areas like machine learning, deep learning, and most recently, what's probably taking the entire planet over, generative AI. We'll just spend, maybe a couple of minutes on each of these areas. Machine learning, like we know, is us trying to train systems to pretty much, think and act like we do by throwing in huge amounts of data at them and then trying to teach them to either, do tasks like classification, where you're trying to separate out the data into any one of your final labels. Sometimes, we just give them data in an unsupervised fashion where you do not exactly try to teach it what to do, but then it looks at all these huge amounts of data and then tries to break it up into groups, the clustering kind of an approach. So machine learning, essentially, there are three different flavors. Once again, the supervised learning techniques. Then we have a lot of unsupervised learning techniques. Then we have the reinforcement learning, wherein probably things like teaching a computer how to play a game, like a trial and error kind of a technique. So these would be, once again, subset of techniques under machine learning. Much better improvement over machine learning, something that is even more data intensive and computationally intensive, happens to be deep learning. Again, deep learning as an area, I think, at least I personally feel it picked up hugely since 2012. Once we started seeing some really good results with respect to how convolutional neural networks were functioning, especially for image recognition tasks. And probably, after 2018, I would say last 4 to 5 years, there's been huge amounts of progress in the recurrent neural network or the transformers-based areas, which has once again led to this entire new area of generative AI coming up. So deep learning was extremely good, where we had to train systems, where we could build huge neural networks that would probably take days or sometimes even months to process through millions and millions of data points. But finally, they would be able to learn, how to classify. Let us say I give a picture with maybe 3 faces in it, and a system would automatically be able to tag, which image belongs to which person. So a lot of these image recognition or computer vision related tasks started becoming really simple and efficient with the deep learning. Once recurrent neural networks, long short-term LSTM memory networks, along with, autoencoders and GANs, the generative adversarial networks, these kind of networks started picking up. We have now, delved into this area of generative AI. You open up ChatGPT, it just depends on how good of a prompt that you can give, and you can pretty much get ChatGPT to do any kind of a task that you want. And although generative AI initially began with trying to generate text, now we see that, it is kind of, the use cases are unlimited. You give it a prompt, you pick up any of these, services like, let's say, DALL-E or Stable Diffusion, and you give it a prompt, and it's also able to create whatever kind of images that you want. So in terms of the generative capabilities, I would say, we are making huge strides, and probably this is the area to look out for in the near future. One more term, that once again kind of, ties in very strongly with data science is big data. Because ultimately, for a data science project to be successful, it depends on having access to huge amounts of data, most of the time a wide variety of data, and how well are you able to pull out data from all of these multiple sources how will are you able to, create your data pipeline so that you can ingest and make use of all this data is what is going to give you an edge probably over other companies. So when we talk about big data, again, there's all these famous, the 5E approach, the different variety of data, the volume at which huge amount of data is being generated, the really fast velocity at which it is being generated. And also, because you will have to have probably, newer technologies, probably our traditional older way of doing things with respect to maybe traditional database management systems is no longer sufficient. So this led to, development of a completely new paradigm of hardware and related software products. It could be your, Hadoop or your all your cloud management kind of a thing, all of which came into place in order to handle all this big data. So like I was saying, probably, although there are two completely different areas, there is a small subset of it wherein data science does pull in a lot of concepts from artificial intelligence in order to actually do its work. And the second part that we were talking about, which was big data, probably, I think, going forward, we'll probably see bigger data in the place of big data, depending, it's like the amount of data that is being generated is massive. And this is probably, one of the more recent images that I found on the web. The numbers are staggering. The amount of data that all of us are generating, be it in terms of, the amount of images that we click and post onto social media websites, the amount of official communication that goes through in terms of emails, amount of data that we stream, let us say, because we're watching things like Netflix or using services like Spotify, it is massive. And it is only, going upwards. And, if you notice this graph here, there is probably a 25% increase that is happening year on year in terms of the amount of data that we are consuming and also the associated data that we are generating. So this would be a good place, to also talk about the different kinds of data, both with respect to big data as well as with respect to the actual, data input that comes into any of our data science pipelines. So, the first kind of data that probably that we are all used to, especially in a more traditional sense, would be structured data. You have your data that is, sitting in all these flat files, or it is sitting in your proper, well-designed, normalized database management systems, in probably data that is in the form of a table and, has very nicely defined attributes, rows and columns. So that would be our structured data. This is probably, one of the big areas from which most of the data comes in. But with respect to data science and big data, probably there is a huge influx of unstructured data in comparison to even structured data. Probably 60% of the entire data that we're dealing with currently is more unstructured in nature. Any of these, newer, richer formats of data that we deal with today, it could be images, it could be audio, it could be video. All these kinds of data basically fall under the unstructured data domain. We do have a part of data which is semi-structured in nature. Let us say, data that you're pulling in from your emails or from maybe, some kind of a social media post. There is sort of, some structure to it, maybe some 3 or 4 headers, data that is in the form of an XML file, an HTML document. So there is a little bit of structure, but it is probably not as well formatted as your, data from a regular DBMS. Huge amounts of geospatial data being generated on the fly. All of us are pretty much, continuously logged in, sharing our location. We are trying to probably use maps, to get to some place, or you're trying to track where your package is at. Maybe, you're trying to FedEx something and you're continuously tracking how your package is moving. You're ordering something from Amazon. So there's this huge amounts of location-based data, either with respect to the packages or with respect to our movements, that is being stored and continuously processed. One more, huge class of data that is coming in recently is all this logging data or machine or operational data. let us take, healthcare, for example, or maybe all our wearable devices, let's say my Fitbit or an iWatch that is constantly tracking our vitals, especially more so in the sense of a hospital that is continuously tracking lot of vital information with regard to patients and storing them over time. So again, it could be information that we are getting in from a lot of IoT devices. It could be information, let us say, with respect to agriculture, you're continuously monitoring the temperatures, the humidity levels of the soil. So all this kind of logging data is one more very rich source of data. Other than all of this, especially from a data science perspective, there's huge amounts of open source data that is available out there. It could be all your census information. There are huge data sets about all the COVID patient information. There is information about, let us say, from an economic perspective, huge data sets that are released by World Bank. Okay, so the variety of data and also the scale of data is mind boggling. And then to kind of make sense, in a very real world perspective, most of the data intensive companies probably have all of these kinds of data coming in constantly, around the clock. And so being able to manage, first of all, being able to put it in a pipeline, bring it in to the system, clean it up, make it into a form that is usable, for the data analysts at a later point of time. It's a massive job. Again, moving forward with the technology, one more term that we typically come across, again, that probably kind of seems very similar or allied to data science is data analytics. And then we also hear about business analytics at certain spaces. So again, are they similar or do they, kind of drive one another? I would say probably, data analytics is more like a smaller subset of what all happens under the data science umbrella. The specific part about pulling up insights, after you have defined your problem, after you have, done whatever you need to do with the data wrangling part of it, and then you are now focused on the pulling out the patterns or the insights from the data. Probably, is that subset that data analytics probably mostly concentrates on. And again, under data analytics, we have all these different kinds of approaches. There could be analytics solutions trying to make sense of what has happened. You could be trying to predict what could be coming up in the future. Or, at an even higher level, maybe you could look at all your data and then try to come up with what are, the best ways in which you could move forward in your business. What kind of strategies or planning do you need to do in order to increase your bottom line? So these are all the various different kinds of analytics that go into when we talk about data analytics. Again, one very important, section I feel particularly is data visualization, because however well you do all of your previous steps, you're really good at getting your data, cleaning it, pulling out insights, but unless you're able to present it in a form that actually makes sense to the business users at the end of the day, most of this would be a wasted exercise. And again, so under data visualization, there are various levels of complexity that we can get into. Are you creating, timed reports? Are you creating interactive storyboards? Or depending on, probably that smaller subdomain that you're working with, maybe I can create a social media mashup. How many new users did I get today? Or how many probably deactivated their accounts? Which posts are getting the most traffic? I could have, so these domain-wise mashups, social media analytic related mashup, or maybe a financial, or maybe HR related mashup. So again, just visualization as an area is huge. The scope is kind of pretty much unlimited. We have a lot of open source and proprietary players out there that are providing all these various data visualization softwares and platforms for us. So, those are all the areas to be mindful of when we talk about data science as a whole. Let's move into, the actual data science process itself. And this is a nifty acronym that has actually been coined by Raj. In fact, this is like a proprietary term that we have come up with, because we feel, it kind of really encapsulates what the entire process is about. Since we're saying, it's most of the time taking in data, cleaning through it. swimming through huge pools of data, trying to find some useful nugget of information. The very first step would be defining your problem. Exactly what is it that we're trying to achieve? And, sometimes I feel probably this is the most difficult part of the job to actually get it right. What is it that you're trying to solve, or what is the question that you're trying to answer? Now, based on that, what is the data that is required? Where do I pull it from? Analyzing and exploring the data, doing a lot of EDA. Or again, another term that comes in at this stage is ETL, the extract, transform, and load. Pull in data, transform it, clean it up, load it into the necessary pipelines. We will talk a little bit, later on in terms of the actual data part of it once again. So once you do have your data ready, exactly what kind of model do I need to use on top of this data? Probably is a machine learning approach good for this? Do I need to use some classification based model, or will regression work with this better? Or given the data, features or the characteristics of the data, again, the quality of data also sometimes will push you to making one of these choices. Once you do have, a basic model going, evaluating, how well does it do? What's the accuracy of your model? In fact, there are many more higher metrics that you could go for. And then deciding, is it good enough, or do you really need to change your approach once again? And finally, go ahead and deploy it, and then, make the magic happen pretty much. So those would be all the steps that go into a data science process. We'll just talk briefly through these steps, maybe for a couple of minutes. When we talk about, the step one, which is defining the problem that we're trying to solve, okay, this actually requires a lot of domain expertise as well. A good understanding of the business problem and a good understanding of the underlying domain area. And this is where probably a data scientist, skill comes in. Just the techniques in terms of the programming, or in terms of, having a data set ready and then running an ML algorithm on top of it, I think I would say that is actually the easy part of it. Then knowing exactly what to ask, knowing what kind of data would be needed to solve this problem, is where, a lot of skill and experience of the data scientist actually comes through. And like they say, well begun is half done. If, you're the very first day, if you do not get your questions right, probably the answers that you're going to develop by the end of the process won't really serve you much purpose. This happens to be, probably the most important and the most time-consuming stage within an entire data science journey, the data prep part of it. So if we look at this, graph, we notice that, over 60% of a data scientist job actually goes into just cleaning the data. And, overall, probably some 80% of their entire job role goes to, working in some fashion with the data, either collecting data sets or making use of existing data sets, how to clean it up, how to put it in a form that is suitable for whatever algorithm that they're trying to run later on. Okay. And like we said, probably, the actual output that you get probably is at, step 5 or 6. But in order to get there, you're already spending 80% of your time, effort, money, all of it goes into the data preparation stage. Again, like they say, garbage in, garbage out. Unless the quality of your data is really good, whatever insights that you get from your data science process will not be usable and might not really give you the kind of results you expect. So putting in a lot of, focused effort at this stage becomes extremely necessary. So when we say, data cleaning, maybe, just a few common data cleaning techniques. Let's talk about them very briefly. One, first, even realizing that, you have dirty data. What do we mean by dirty data? There could be a lot of places where, there are missing values in your data. There could be outliers. Probably certain data points are going way above, the whatever range that you expect. Maybe, let's come up with a small example. Let us say I'm a clothing company, and then I'm trying to come up with sizes. And when we say small, medium, large, there are proper measurements that go into creating your garments. Maybe I would have probably 0.1% of the population whose measurements would fall under the outlier values, people who are extremely tall or let us say extremely short. So these kind of data points would skew the rest of the data set. So exactly how do you deal with those? Maybe, certain cases for certain algorithms, you will go ahead and just remove them. In certain cases, we replace the outliers with probably, a predefined value. So again, there are many techniques in terms of how you could clean your data. Again, your choice of your machine learning algorithm or the deep learning network that you'll be using will also determine what kind of cleaning techniques would make sense for that particular stage that you're going to get to later on. How do we deal with, again, missing values also? First, identifying that there are a lot of missing values. Are you going to replace it with the most common, maybe you could take the mode of the remaining data and use that at all the spots where some data is missing. Or maybe if there are certain rows of data where a majority of the values are missing, one choice you would probably make is remove those rows altogether. So again, decision making at this stage is complex. There are many techniques that you need to go through, and the kind of techniques that you use in order to clean your data will have a huge impact on the kind of metrics that you actually end up with after you implement your process. All your accuracy levels, your F1 scores, all of those will be impacted by how well you're going to clean your data. So this itself is, one complete science on its own. There are a lot of times when bias creeps into data. Maybe, especially if we are trying to get in data from users through the form of surveys or forms, depending on the kind of user population that I target, obviously there's going to be both bias and a question of reliability as well that creeps into the data. This is actually has been shown to be a problem even with respect to a lot of image data sets that were used to train the initial, image recognition networks, that there was a lot of gender-based bias, there was a lot of race-based bias inherent in the data sets themselves, which in turn led to the algorithms probably, also picking up that bias when they were trying to learn to work with that data. So in terms of, data quality, once you do have your data, you have used all your data cleaning, data wrangling techniques, before you actually push it down the pipeline, what are some questions, that you need to be really comfortable with before you go ahead and start making use of the data? So one, is it factually correct? What's the accuracy of your data? Probably the most important one. Second, consistency. Is everybody's view of the data the same? Okay. This is again, anybody who has worked with even a simple, really small database for that matter, would have faced the situation where probably everyone's definition of the data kind of keeps shifting depending on the department that you belong to, or depending on the kind of view you have of the same data. So making sure that everybody's talking about a consistent, definition of the data. How easy is it to access? You might have all this variety of data, huge amounts of data, but what if you're not able to pull it out on a timely basis? What if you're not able to clean through it and make it into a form that can be supplied to your algorithms down the line? So is it usable? The timeliness of the data, especially, there are probably, I would say all huge big companies or organizations, they would have their DBMS systems, they would have huge data warehouses, they would have their OLTP systems, their OLAP systems, they would have data on the cloud. So, bringing in data from all these disparate sources and doing it so that it doesn't hurt the cadence as such. You have to ingest it right at the time that it is being actually captured within your systems. Cost efficiency. Like we said, 60 to 80% of your time and effort is being spent only on getting your data, cleaning it up. So obviously, there's also going to take a lot of resources, going to cost a lot of money. Are we doing it in the best efficient way possible? And most importantly, identifying if we have all the data that is actually necessary for us to go ahead and do the job that we're planning to do. So all of that would be the intermediate steps. So first we define a problem, Then we go ahead and work with all of our data. And then finally, we come to the actual implementation of the model itself. And over here, again, choosing the right kind of models. And as we are all noticing, there is huge amounts of improvement, or there is a lot of technical advances that are happening pretty much on a daily basis. By the time we got comfortable with ChatGPT, there was ChatGPT 4, and then we probably experimented a little with DALI, and then now they've made it a paid service. There are many more free open source variants out there that are available. So just keeping in line with all this, with the trends that are happening, staying up to date with all the new kinds of algorithms that are being released. This is a huge job in itself. And then using all this information in order to make your optimal choices for this particular problem that I'm trying to solve. Would this kind of, would supervised learning be good? Undersupervised, will a support vector machine do the job? Or do I need to go for a decision tree? Or maybe, would a naive-based model suit me better? So making the right choice of algorithms, tweaking them up. There is a lot of hyperparameters that also need to be decided. All of this, again, takes a lot of trial and error, takes a lot of experience from the data scientist perspective. And once you do have, some results after you have implemented your models, what kind of visualization will actually make these results usable? That would be the final step. Okay. So now, let's move on to probably talking about some real world use cases. And before we go ahead and, jump into some use cases that probably that all of us are comfortable with, I have, maybe a more hypothetical situation here that kind of walks us through all those, data science steps that we just, looked at. So for example, this could be any kind of hypothetical company, maybe companies that offer services, like it could be Spotify, Netflix kind of a thing. And maybe it could also be, some kind of a banking or a financial institution. Main objective being, they want to prevent attrition, and they want probably, some kind of renewals of their subscription to happen. And while they're doing this, they also want to ensure that, they're able to upsell or create more campaigns for the high value customers. So, this would be step one, defining what your problem is. And also, how exactly are you going to quantify it? I do have this problem. I have a lot of data and I'm trying to solve this problem. But when do I say that I have achieved some desirable amount of success? So you need to quantify what kind of results. It might not be easy in all cases, but at least, for this particular case, maybe, you have a current renewal rate of X and you want it to be increased by some percentage quarter on quarter. Probably most companies, they do have a lot of business rules in place, and based on that, they do customer targeting. But if you were to approach this exact same problem from a data science perspective, a simple probably approach would be, I take in all my list of customers and try to build a binary classification model. Again, classification techniques are from the supervised section of machine learning. And binary classification may be, yes, this set of customers will probably leave the company or lead to attrition. This set of customers are probably the ones that are most likely to stay back with us. So if you're able to build a really good model and be able to classify your customers into these two classes, stay versus leave, and then take these, the second class of people that you think probably might leave, and then create some kind of customized campaigns that might convert them back to your customers. So that could be, a data science way of actually trying to solve this problem. And a success scenario would be, just assume, from your entire set of customers, you are able to identify 80% of your customers who are probably most likely to leave. So what are some data points that could help us? Your customer profile information, all the user logging information, probably customers who are not logging in at least even once a week onto the service are probably customers who are thinking of leaving. That could be one way of understanding that data. So you will have to actually, again, spend a lot of time in understanding what data is even required in order to classify your consumers into these two classes, and then work through the data. But if you are able to successfully identify who the future advertisers are, then you can actually go ahead and then make use of your business logic and create campaigns that will ensure that they do stay back. Moving on to probably the most I would say interesting or exciting part of the webinar, where we talk about the real world use cases. One thing is it has applications across domains. That's, I would say, probably there is no area that is left untouched as of now in terms of not having a data science application out there. Most these are probably the most common ones that we are all used to. One, when it comes to travel, all of us trying to either book our flights, book hotels, book an Airbnb. In fact, Airbnb is a completely heavily data intensive company, right from the listings to showing you the correct results based on whatever criteria that you're trying to search for. They have their own proprietary algorithms in terms of building their data pipelines, in terms of searching through and showing the search results. So all this dynamic pricing that we get to see, predicting your flight delay, all of these are applications within the travel domain. Marketing probably is something that all of us are impacted with heavily. Maybe it could be any of these. Let's say Amazon recommending me what I ought to buy next. Instagram bombarding me with all these, shopping pages. So probably both marketing and social media, they make heavy use of data science techniques in order to retain their customers and also in order to do cross-selling and upselling. Healthcare is an area where, again, huge, massive applications that are already in place. And, we are going to see a lot more applications come up in this area. All this, continuous monitoring in terms of all the wearable devices, trying to make use of all the medical imaging data that is available and trying to predict, probably be able to get there quicker than regular doctors can in terms of identifying tumors. All these, apps that constantly track users' data. It could be, menstrual cycle trackers, apps that help people get pregnant. It could be apps, that are especially, for the more risky patients out there, trying to give them timely advice in terms of what kind of, precautions they ought to take. So healthcare is an area that has a lot of booming uses. And in fact, I think, probably all of us are to some extent making use of this already. Like we've said, sales is an area, again, in terms of the different kinds of campaigns that are being created and customizing them based on the user demographic, based on, probably the kind of plans that Netflix makes, different across US, across geographies. Maybe, in developing countries, the kind of plans they offer are very different compared to the plans they offer in US, maybe. So creating, all these different kinds of offerings and tailoring it or customizing it based on your user profiles, that has been huge upcoming area. Data science is being used heavily across all banking and financial institutions. One, in terms of anomaly detection, any kind of fraudulent transactions happening before deciding, whether or not to give out a loan, in terms of risk detection, in terms of deciding whether a claim is right or not. All of these make heavy use of machine learning techniques. Again, one subset of the data science area. And all these, latest developments that we are kind of enjoying pretty much already, self-driving cars, having robotic appliances, pretty much to do everything around the house. These are all probably the more newer and exciting opportunities that are coming across because of this heavy usage of data science. I think, I'll probably take another 5 minutes to finish off the applications, and then we can have the last 10 minutes for a question and answer session. This is, one use case that I am particularly excited about, because Netflix make huge usage of, massive amounts of data that they collect in terms of, all the logging information of each user. What kind of shows do I watch? At what time do I sit and watch them continuously? Does a user probably tend to watch them more during night or during weekends? How often do they actually pick up the recommendations that Netflix gives? And then do they watch them through and through? Are they completing it? Okay, all of this information is being captured, and then they have multiple ways in which they use the data, and also they have their own in-house or proprietary algorithms built on top of this data that helps them give us all these really good personalized recommendations. Every time they say we are sure you're like this, I'd say 80% of the time they are spot on in terms of suggesting what new show I should be watching. They also make heavy use of this information in order to even determine what kind of content they need to develop going forward. You see, the massive success of shows like Stranger Things or Squid Games. That is kind of telling them, a lot of analytics done on top of all this watching information is actually telling them what kind of shows they need to invest in or what kind of content they need to create. In fact, they make such huge use of data science techniques that probably, for a small 10 episode show, they might have some 13 to 15 million frames of individual images across the entire show. And then they sift through all those millions of images in order to decide, what artwork, the thumbnail that I see, even that is being decided by data science algorithms at the back end. And again, for the same show, the thumbnail that I might see might be really different from what another user sees based on, our own personal choices as such, or based on our own profiles. These are again some of the more common common real world applications. One, social analytics by all of these social media companies trying to suggest, who could be a part of your friend group, or these are people you might know and want to connect to. Facebook, Instagram, LinkedIn. In fact, LinkedIn's entire business actually started going up heavily once they started making use of these data analytic techniques in order to give those suggestions as to who should be included within an individual's network. Amazon, improving your e-commerce experience right from the minute you start shopping till the minute, that you actually receive the package and give your feedback about it. Sometimes, when there are problems that occur, the entire pipeline as such, again, heavily data-based. Uber, making sure whether, it could be deciding on the smallest or the shortest path to get you from place A to place B, or if it is something like Uber Eats, promising that they will deliver your pizza maybe like in 15, 20 minutes and actually ensuring that it happens. All of this, once again, makes heavy usage of data in the background before they're even able to make those claims and actually, try and follow them through. All banking financial institutions, both in terms of improving customer experience, in terms of devising new plans or products, again, very data intensive. Companies like Airbnb, in terms of improving the search quality, in terms of improving the kind of listings, in terms of even suggesting, what should be the rent for any one property that I would want to list. Okay. Again, heavily data intensive and makes use of a lot of data science principles. All kinds of recommendations that we get from Spotify, YouTube, Netflix, recommendation engines across the board, get heavily data science based. I would try, probably finish up with saying, again, one reason why data science is like so attractive right now is this is like, for the current year, data that has been released, actually for 2022, that if the median income across job groups within US was around $51,000, you see that a data science professional is very easily making double that compared to all sorts of job profiles put together. And also this is, salaries across industries. You would see that, whatever the industry or the domain that you pick up, they are probably being paid almost, towards the higher end of the salaries within any individual job domain. So maybe, this is one more reason why as a industry or, as an area, it has become extremely attractive. I personally feel, there's a lot of these technological improvements that are happening, the open source movement, the cheap availability of technology, and then this huge learning community, open source learning community that supports each other online. These are also reasons for this entire area to actually bloom so much. And I would like to finish off, with this quote. At the end of the day, I think, it is an area that is trying to change the world for the better. maybe, change a patient's life, or maybe try and make things easy across domains, across geographies. And that is the reason why, probably all of us are being pulled towards this data science area. So that's it from my end. Free for questions. If, you could post it in the chat box, or we could take it from there. It's over to you, Raj.
Thanks, Aparna. That was a great session covering a wide range of introductory information, use cases, some reasoning behind, and several things. So really appreciate that. So what we'll do before we go, I just want to share a few next steps and resources, free resources for everybody. A lot of links are in the chat. So I'm just going to quickly go through that as next steps. So if you wanted to continue the journey, we are trying to keep it on a monthly basis, one free webinar, if not more. And you could join in several of these meetup groups, which we have for different things, whether it is big data and AI, one-on-one basic sessions, which we do. Then we are part of Google. We are a Google partner, and then we have something called as GDG, which is a Google official community, Google developer group. So we are organizers in the Bay Area for Cloud Santa Clara GDG and the GDG Santa Clara in general, beyond cloud and overall Google and other related stuff. So it's a community effort. So we have organizers for that, and we have a few other different job and different kind of meetup groups where you can register. The link is provided. We also have curated a lot of free training resources. So it's not necessarily developed by us, but I think it's like curated, and especially in the last some period of time, the economy has not been doing great. A lot of people having impacted. So we wanted to give back to the community and society. So we thought it may be a good thing to just pull out resources for the people who cannot necessarily afford trainings and different things. There is a lot of resources available. So our team curated all of that and just pulled very common areas where you can get started with several of these things, technology pieces, and at least in the core ones, like the foundational ones. And we have curated resources around that, so you can help yourself with that. We do offer some public trainings where individuals can join. Most of our services or businesses driven towards corporate, small and large companies, but we have individual trainings, and there is some of the upcoming training. So that link is shared if you have interest and want to join a paid training and take on more of a hands-on approach and learn things in detail. That's an option. We do have a free training on ChatGPT. So that's very popular. It's a very highly polished training program, and at least for the basic level to get started, it is available. So that link also is shared in the chat. So feel free to register and join that e-learning on-demand training for free. We have several trainings actually. So not only the ChatGPT, but e-learning format. Most of our trainings in general are instructor-led training, the way we are doing right now. But there is a whole section for e-learning on-demand trainings where you can buy, or there are some few free ones as well. So feel free to browse through that and use the way you would like to. In general, as just to recap, bigdatatrunk is a professional training services company based out in US, California, and the Bay Area, serving a lot of Fortune 500, Fortune 100 companies in corporate trainings, in technology, soft skills. There are several areas which we have, and you can browse through different skills. AI and data science is our main forte. The majority of the courses which we have, it's in part of that. And we have e-learning and other things, as we talked about and shared in everything. We have been there for a while. We have partnership with several big corporate giants. So we hope that you enjoyed the session, and you can be part of the next webinar, or however you can benefit from the information which we can share. We're just trying to do our 2 cents and share with the world. So thank you very much for joining.